So the first video of 11.1 is going to talk about area of parallelograms and squares and rectangles, because those are parallelograms as well. So think about it. What is area? How is it measured? And what do you need to do to figure out area? We've done area from when we were in elementary school, where we counted squares inside of a graph. We have some formulas for area in our head. We've gone through some of the process already as we go through, but area is the space inside of a shape, whether it's a parallelogram or a triangle or circle or hexagon. It's how much can fit inside the shape, and we measure it in units squared, inches squared, square feet, anything like that. So width of a rectangle is 5, length of its diagonal is 13. What's the area of the rectangle? So let's get a rectangle here. We have the width is 5 and the diagonal is 13. So area of a rectangle is length times width. Alright, this is probably a basic one that we've seen from when we started doing area. Either way, since this is 5, this is 13, this side has to be 12, so the length is 12 and the width is 5. Let's rewrite that. 12 times 5, and 12 times 5 gets me that the area of this rectangle is 60. So area of a rectangle, something we got to write down. We're going to have a bunch of different formulas that all look pretty similar, but we got to put them down separate so that we can remember which one's which. Area of a rectangle is length times width. Now, a special case of a rectangle is a square. A square, the only difference is, now when I go to do length and width, they're actually the same. Since they're the same, length times width becomes either length times length or width times width. We're just going to use S for side. Any side length is whatever that number is squared, gets me the area of this square. So here's an example. We got Joan makes a quilt that's 4 feet by 16 feet. If she has enough to make a quilt that covers the same area, but she wants to make it 8 feet wide, how long will it have to be? So we've got two quilts, one that's a rectangle and one that's a square, or not a square, a different rectangle, but instead of 4 and 16, it's 8 and X. So it'll be closer to a square, but we'll have to figure that out to see if it actually is. So area of the first one is 4 times 16. When you take 4 times 16, you get 64. So the area here is 64. Now that area has to equal the area over here, 8 times X. And X is 8. Problem number 2 is one taken from an ACT. So area does show up on the ACT a lot. We got to be ready for that. Rectangular room is 2 feet longer than it is wide and has an area of 120 square feet. How many feet long is the room? So we've got a rectangular room. It is 2 feet longer than it is wide. So let's call this our width. And this side, it's 2 feet longer. So our length is 2 plus W. Now, because this is multiple choice, we can do trial and error. We can see what happens when I plug in 10, 12, 22, 29, 31 in for W to see where do I get 120. What we could also do is area equals length times width. What we end up having to do at this point now is we get W squared plus 2W. We're going to have to factor. 0 equals W squared plus 2W minus 120. So we need to find two numbers that multiply to negative 120 that add up to 2. The two numbers we get are positive 12 and negative 10. What's special about those two numbers is those are actually 12 and 10, the length and the width. When we go to solve, I get W equals negative 12, and I get W equals 10. Now the only issue is you can't have a negative width. So the width is 10. So right here, width is 10. And up here, the length is 12. The question said, how many feet long is the room? So we're getting 12. Most common missed answer is going to be 10 on a problem like that. Area of a square is 144 square feet. What's the length of the diagonal? So now we're taking into effect area as well as we're going to be using our 45, 45, 90 triangles because we're looking for the diagonal of a square. So area is 144. That's equal to sides squared. So when I take the square root of both sides, I get S is 12. So each one of these is 12. Now, we could do Pythagorean theorem to get the diagonal. We could do our 45, 45, 90 proportion. I'm going to use that 1 over leg equals square root of 2 over hypotenuse. And my leg is 12, so 1 over 12 equals square root of 2 over x. When you cross multiply, x is 12 square root of 2. So, area of a parallelogram. What do we know about it? We know right here there's a height h. I'm going to label this base up here as b. We still have a base. We still have a height, a length, or a width, just like we do with rectangles, but it doesn't look like a rectangle. It's a slanted rectangle. So what we're actually going to do is I'm going to take this part of the parallelogram. I'm going to move it over to this side. Let me send this to the back. And when I line it up over here, take a look at what shape it forms. When I brought this from the left side, which made it a parallelogram, over to the right, now I have a rectangle. Because this height is drawn so that it forms a right angle. A parallelogram is a rectangle just with the pieces moved around. So it's still base times height or length times width, however you want to look at it. Area of a parallelogram, base times height. So let's find the area of this parallelogram. We know the base is 30. So the area is 30 times the height, but I don't have the height yet. It's right here. I have a 30, 60, 90 triangle on the side with a hypotenuse of 20. So 1 over leg and square root of 3 over leg and 2 over the hypotenuse. So I need the side across from 60, so I'm not going to use that one. Square root of 3 over x equals 2 over 20. Cross multiply 2x equals 20 square root of 3. Divide by 2 and get at that x is 10 square root of 3. So times 10 square root of 3. Go ahead and multiply those two together. Multiply the numbers on the outside. 10 times 30 is 300 square root of 3. Now let's take a graph. Let's do the same thing. Let's plot these points, figure out what type of shape it is, and then find the area. -4, -3 is point A. 2, -3 is point B. 4, -6 is point C. And -2, -6 is point D. So when I draw in this rectangle, or I'm sorry, not this rectangle, when I draw in this shape, it looks like a parallelogram. And remember, to find parallelograms, opposite slopes have to be the same. So on this far right side, I go down 1, 2, 3 to the right 2. Here I go down 1, 2, 3 to the right 2. And then the two horizontal ones are parallel also. So I do have a parallelogram, so I can find the slope, or I can find the height and the base. The base, just count left to right. 1, 2, 3, 4, 5, 6. This length is 6. And when you draw a height, you want to draw it vertical, straight up and down, forming a right angle. The height of this parallelogram is 3. Area is base times height. So the area here, 6 times 3 or 18. And our last example, you see these types of pictures a lot on the ACT. All you need to do, honestly, is break it into multiple shapes. Let's go ahead and draw these two lines across. So now I have three rectangles. This top rectangle has an area of 6, 1 by 6. This one's also 1 by 6. The height here is 1. This part here I need to figure out. Since the entire top is 6, this left side's 2, this right side's 2, this middle part's 2 also. So 1 times 2, area in there is 2. So the area of everything, 6 plus 2 plus 6, and that is 14.